Hi, we have the AP Physics 1 past paper 2021. We are discussing the section free response question. We have the question number 2 which carry the 12 point. In this question, a group of students is investigating how thickness of a plastic rod affect the maximum force with which the rod can be pulled without breaking. Okay. The two students discussing the model to represent how effects depend upon the rod thickness. Student A claim the effects maximum is directly proportional to the radius of the rod, while the student B claim the maximum force is directly proportional to the cross-sectional area of the rod. Area of the base of the cylinder shaded gray in a fig below. The area is discussing here. Okay. Now the question is student have the collection of many rods of the same material. The rod are all of same length but come in a 6 different thickness. Design an experiment to produce the determine which student model if either correctly represent F maximum depend upon the rod thickness. In a table below, list the quantities that would be measured in your experiment, define the symbol to represent each quantity, and also list the equipment that would be used to measure each quantity. You don't need to fill in every row, you need the additional row, you may add them to the space just given the table. So there is a quantity to be measured, symbol to the quantity, and the equipment for the measurement. Next one, describe the overall procedure to be used, referring to the table, provide enough detail another student could replicate the experiment, including any step necessary to reproduce the experimental uncertainty. As need, use the symbol defined in a table or include simple diagram of the setup. Okay. Now, the first we have to take the rod radius. Symbol of the radius is R. We use for this the vernier caliper or the micrometer screw gauge. Then the next thing we have to measure is the maximum force before the braking. F maximum. For this we use spring scale or the system of weight, masses and the hanger with the clamp setup or the force sensor. Different apparatus that available from the school laboratory can be used to measure the maximum force. Now what's the procedure? So we use the vernier caliper to measure the diameter. So we have to find the radius. So we should divide it by 2 to get the radius. One clamp and firmly to fix port. Attach the hanging mass holder to the other end of the rod. Gradually add masses. Let's say 1 kg at each step. Increasing the force, F is equal to mg. We have the mass, g is the gravitational constant, acceleration constant. So we come to know the what is the force at that moment. Continue adding until the rod break. Record the force F maximum at the instant it break. So repeat the step for multiple rod of the same thickness. Calculate the average force for that R. Reduce the experimental uncertainty due to material variation. Next, repeat for all 6 thickness. We have the 6 different rods of the different thickness. So we have to repeat for all 6 thickness. Same above the procedure. To further reduce the uncertainty, let's use the force sensor to record the peak force digitally for the accuracy. Okay. Now the next part of the question, for the rod radius R naught, it is determined the F maximum is F naught. Okay, as indicated by the dot on the grid below. Here it is. The two students model for the dependence of F maximum on a rod radius clearly label each A and B corresponding to appropriate model. So given the model the two students discussing, we have to draw the graph. One is saying it depend upon the radius, one is saying it is depend upon the cross-sectional area. So we have to draw the graph on this given scale. So let's say when the students say F is maximum directly proportional to the radius, so it is directly proportional. If R is increasing, force is increasing linearly. So this is the model A. Then if we say the second student, it depend upon the area. Area is pi r square, so graph is like that. A curve one which is going to upward quadratic curve, parabola you can say, starting from the origin. So f maximum is proportional to r square. You can say pi is the constant. So this is the student B model. So both model crosses over the R naught, F naught. So that's the situation here. It is. Now the table below show the result of measurement taken by another group of students for the rod of different thickness, radius and force. You can see the when the radius is linearly increasing, it's symmetrically increasing, but the force increases rapidly. 40, 123, 25, 20, 900. On a grid below, plot the data point for the table, clearly scale and label all the axes, draw either straight line or curve the best representing the data. So we have to know from week 900. So one big scale is for 200 for the force, and the one big scale is for the 0.5 millimeter. It stand for the radius. So I have plotted all the dots according to the table, and the curve is representing like that. Okay. Now, the force increases much faster than the radius, so graph is curved. Hence, the curve bends upward shape look like parabola, not the straight line. Now, which student model is more closely represented by the evidence shown in a graph you drew in a part C? The result we have got from the part C. Which model is closely related? F maximum directly proportional to the radius, F maximum directly proportional to the cross-sectional area of the rod. So section B model is more closely represented by the evidence. Plot C is concave up, curved up, which matches the squared relation R square rather than the linear one R. So therefore, evidence supports the student B model. F maximum is proportional to A pi R square. Thick rod, more material resisting the pulley force. Thus, the resistance depend upon the area, not just the length of the radius. So that's the solution. If you have any query, kindly ask in a comment. If you like the content, kindly subscribe and share with your friends. Okay, take care.